Now let us see the first example of the chapter. Example number 1. Determine whether the function f of z is equal to x upon x square plus y square plus I into y upon x square plus y square. This is the function given. Okay, fz. We have to show that this function is analytic. We have to find out whether this function analytic or not. Okay, for the analytic function, what we have to find out, whether we have to show whether this function satisfies CR equations or not. Okay, this function is in Cartesian form. That's why we have to use Cartesian CR equations in Cartesian form. Okay, now let us see if let f of z is equal to u plus iv. This is our basic assumption. But to find out first u and v by comparing these two. Okay, by comparing what we get, u is equal to this real part x upon x square plus y square, and v is at the part which is attached to I, which is y upon x square plus y square. Okay, now we have to find out the derivatives of u and v with respect to x and y, the partial derivatives, where with respect to x, while taking derivative with respect to x, you have to keep y constant, and while taking derivative with respect to y, you have to keep x constant. Now let us see one by one. W by x, that is derivative of u with respect to x, is equal to, see, in this is u, and in the numerator and denominator x is there. That's why you have to use u by v rule here. Okay, what is u by v rule? V into x square plus y square into derivative of x is 1, middle side is minus u into derivative of this denominator with respect to x. X is present here only, that's why derivative is into 2x. Y is a constant regarding x, that's why its derivative is 0. Okay, no need to write addition plus 0 here. Now divided by v square, u by v rule, denominator is v square, that is x square plus y square bracket square. Okay, these are a simple chain rule of derivatives. Now simplify this, which is equal to x square plus y square minus 2x square upon denominator same. 1x square minus 2x square becomes minus x square plus y square. Denominator is same. Now, derivative of u now with respect to y we have to find out. That is uy. Now y is present in the denominator itself. That's why x is a constant, keep that as it is, and we have to apply 1 upon x derivative of here. What is derivative of 1 upon x? Minus 1 by x square should be applied here. That's why it is equal to minus x is a constant, 1 upon this bracket square. Bracket, keep treat it as x. That's why 1 upon x derivative is minus 1 upon x square into, this is not only x, that's why we have to multiply the derivative of this term here. This is chain rule. What is derivative of this with respect to y? Is 2y only. Okay, because x is constant, should be multiplied here. That's why final answer is minus 2xy denominator, and numerator is this minus 2xy, denominator is same. Okay, now similarly we have to calculate derivatives of v with respect to first x and then y. Now w by x is vx, derivative of v with respect to x. Now x is present in the denominator only, that's why derivative of, while taking derivative, y is constant, and 1 upon x derivative should be applied here, that is minus 1 upon x square here. Okay, and multiply by the bracket derivative here with respect to x is 2x. Now final answer is equal to minus 2xy in the numerator, denominator is bracket square. Now next final, w by y, that is derivative of v with respect to y first. Y is present in the numerator and denominator itself, that's why we have to use u by v as we had used in here. Okay, now v into derivative of numerator y is 1, derivative we are taking with respect to y. Now x is constant here. Now v into derivative of y is 1 minus y into derivative of this bracket v is 2y with respect to y. X is constant. Okay, divided by v square, that is bracket square. Now simplify this, x square plus y square minus 2y square divided by this bracket square as it is. Now x square y square minus 2y square becomes minus y square divided by this bracket square. Okay, now this we have just calculated 4 derivatives. Now we have to check whether CR equations get satisfied by this function f of z or not. What are the CR equations? Here ux must be equal to here. ux must be equal to vy, where ux is this and vy is this one. These two are not equal, and uy must be equal to minus vx. This is uy and vx are same, which should not be same, it must be minus vx. That's why this is not equal to minus vx. That's why this function is not satisfying the CR equations. Above function is not analytic. Therefore, these are the CR equations not satisfied by f of z. That's why above function f of z is not analytic. Okay. Now next example. Prove that f of z is equal to sine hyperbolic z. H means sine hyperbolic z is an analytical function of z. We have to prove this function is analytic. That means we have to prove this function satisfies CR equation. For CR equation, we have to find out u and v. Then we have to calculate their derivatives, and then we have to compare the CR equations. First, function is given in terms of sine hyperbolic. We have to find out the function in terms of u plus iv, that is real part and imaginary part, to get compare. In earlier example, fz is given directly, right, like u plus iv. That's why by comparing we can find out u and v. But in this particular example, this function is not given in the form of u plus iv. We have to find out by simplifying this function into u plus iv. Then comparing we can get u and v, and then after that we can calculate derivatives. Okay, now let us see how to derive those. Fz is equal to sine hyperbolic z, and we know sine hyperbolic z derivative definition is e raised to z minus e raised to minus z upon 2. Angle is z here. Okay, now again take half constant outside, e raised to z minus e raised to minus z. Now we know z is equal to x plus iy here. Put this z is equal to x plus iy here also, x plus iy, which is equal to half as it is. Now separate out the base here, e raised to x into e raised to iy. We can separate out the base, minus e raised to minus x into e raised to minus iy. Okay. Now in next step, we have to put e raised to iy value here. What is e raised to I theta? Cos theta plus I sin theta. That definition we are going to use here, here and here, where I is there. Okay. We can't use here because I is not there. The definition is e raised to I theta. I should be there. That's why here and e raised to minus iy here we have to use cos y plus I sin y here, cos y minus I sin y here. Therefore, fz is equal to half e raised to x into the same step we are carrying forward. Half is as it is, e raised to x as it is. This value is cos y plus I sin y, minus as it is, e raised to minus x as it is, cos y minus minus I sin y. Okay, these are the two definitions of these two exponentials. Okay, now multiply these two inside the bracket. We take half as it is, e raised to x cos y plus I e raised to x sin y, minus e raised to minus x cos y, minus minus plus I is there, e raised to minus x sin y. Now take from these two cos y common, or take add these two first, and plus these two take from this you can take cos y common here also, and take common itself. Okay, keep that as it is first. Now from this two take cos y common, and e raised to x minus e raised to minus x as it is, and take this half here to each term, half, plus I is there here. From these two I common and sin y common, and e raised to x plus e raised to minus x is there, and take this half inside here. Okay, now what is this? This is the definition of sine hyperbolic x, and this is definition of cos hyperbolic x. rest of the terms as it is. This is the function we have derived into u plus iv form. Now clearly this is your u, this is your v. Okay, now let us define u is equal to this one plus v is equal to the function which is attached to I, sin y cos hyperbolic x. Now take derivatives to find out whether CR equation gets satisfied or not. Now first ux, w by w x, derivative of u with respect to x. X is present here only, that's why cos y is a constant. Sin hyperbolic x derivative is cos hyperbolic x. Vx, derivative of v with respect to x. Sin y constant, cos hyperbolic derivative is sin hyperbolic x. And uy, derivative of u with respect to y is sin hyperbolic x as it is. Cos y is a normal trigonometry, derivative of cos is minus sin y. And vy, that is derivative of v with respect to y is present here only, cos hyperbolic x as it is, sin y derivative is cos y. This is vy. Okay, now by comparing this, ux value is same as vy. These two values are same, that is ux is equal to vy, and uy and vx are same in but in opposite in sign. That's why uy is equal to minus vx. Okay, that's why CR equations satisfied by this function. That's why function f of z is analytical function. Okay, now let us see next example. Fz is equal to mod of z square is given. Find whether fz is analytical or not. We have to find whether the given function fz is analytic or not. Okay, let us now of course we have to derive this function into u plus iv form. Now mod z square, let f of z is equal to mod z square. We know mod of z square is nothing but modulus of z. Definition on first page we have seen that x under root, mod z is under root of this, we know mod z is under root of x square plus y square. Okay, where z is x plus iy. Okay, this is the definition. That's why mod z square means just take the square root on both sides, we get x square plus y square. Now this is the function. We have to find out u and v, that's why just write here plus 0 I. That's why v becomes 0 here. Okay, now this is u, this is v. What is u? A real part. What is v? The function which is attached to I. I is not there, that's why we have just write 0 I here. Sure, for comparing only. Okay, now let u is equal to this real part x whole plus y square, and v is equal to this is 0. Obviously this is not analytical function because 0 derivative is 0 everywhere. Now let us see w by wx, derivative of u with respect to x, y constant is 2x. W by y, derivative of u with respect to y is 2y. X is constant here. And w by wx is 0. W by y is 0 again. 0 derivative is 0. From these two, obviously, ux is not equal to vy and uy is not equal to minus vx. Therefore, function fz doesn't satisfy the CR equations. Therefore, fz is not analytic function. This is one of the simplest example. Let us see next example. Show that u, this function is given like this, x cube minus 3xy square plus 3x square minus 3y square plus 1 is harmonic function. First we have to show this function is harmonic and hence find corresponding analytical function. Okay, what we have to do? Here u is given and we have to find out first question whether u is harmonic. You have to show that first and then find corresponding analytical function means we have to find f of z which is equal to u plus iv, and u is given, that means we have to find other function v. Okay, first let us see let us prove that this function is harmonic. Now we know if u is a harmonic function then it must satisfy the Laplace equation. This is the Laplace equation if harmonic function satisfies this Laplace equation. We have seen this. That's why this is the definition of harmonic function. Now you have to just verify this equation. Double square u by double x square plus double square u by double y square. That means we have to find out just double derivative of u with respect to x first, then y. First, let's calculate single derivatives. W by x means derivative of u with respect to x. Y is constant. The x cube derivative is 3x square. Here y constant as it is. X derivative is only 1. That's why 3y square as it is constant. And x square derivative is 3 to the 6x. This is constant with respect to x. That's why the derivative is 0. This is w by x first derivative. Now take derivative again of this function, we get second derivative. W square we have u by x square becomes, this is 3 to the 6x, and here this derivative is 0 because x is not there, plus 6x derivative is 6. Now similarly w square u by y square we have to calculate first derivative. W by y derivative of u with respect to y. X is constant here, that's why here only y is there, that's why y square derivative is minus 6xy. Okay, plus here this is derivative 0 and here minus 6y. Now take second derivative of this, we get with respect to y, we get minus 6x as it is because it is a constant, and here minus 6y derivative is minus 6. Now add these two, we get w square u by x square plus w square u by y square. Addition obviously 0. Okay, that's why u is a harmonic function. First question we have just finished. Now we have to find out second analytical function. To find analytical function f of z is equal to u plus iv, this is our assumption. That is, we have to find v, other variable. Okay, this is a very important question. If one function is given, how to find out second function using CR equations. Okay, because function is given already harmonic function, that's why u and v must be satisfies fz is given already analytical function, that's why u and v must satisfy CR equations. Let us see how to find out. First, using CR equation, first equation is ux is equal to vy. Already we have calculated these two equations, those two derivatives. Okay, here ux and vy we have to v is not there, we have to find out v. Okay, now use this equation first. Vy ux is equal to vy, this is CR equation, that's why vy is equal to this, vy must be equal to, thereby v by y is equal to ux is this, put this value here. Okay, now one we get from this equation. Okay, vy. Now we have to find v. That's why to cancel out this derivative effect, we have to take integration on both sides with respect to y. Okay, integration rules are same everywhere. With this is a partial integration, like partial derivative means taking integration on both sides with respect to y, means taking putting x constant. Okay, that's why here taking integration we get derivative and integration gets cancelled, we get v is equal to 3x square, derivative is 3x square is a constant, take outside from the integration, and integration of 1 here is y with respect to y. Okay, minus 3 as it is, y square integration is y cube by 3, this 3 gets cancelled, plus 6x is a constant, derivative of integration of 1 is y. Now we have to see, this is not a normal integration. To keep plus constant, we are generally we take plus c constant for indefinite integral. Okay, but here we taking partial integration. Okay, that's why here if we integrate with respect to y, we have to add function, not constant, function of opposite variable, that is here y, then here x. Remember this. Okay, now v we getting this, call that number 1. Finding out v means finding out v without the phi of x, that means we have to find out now phi of x. Okay, now we already used this equation, first equation, CR equation, ux is vy, and other equation is uy is equal to minus vx. This we are going to use here. For in this equation we are finding v, that means here derivative of on, we already know uy. Okay, that we already get it here v, that's why next step will be from here differentiate this equation with respect to x to get vx. Okay, then we can put that value here to use this second equation. Now differentiate, give above equation with respect to x, we get vx, that is w by x is equal to derivative only. X square derivative is, now differentiating with respect to x means y constant. The 3 to the 6 x y. Here y cube derivative is 0. Here 6x derivative, xy derivative is only 6y. Plus derivative of phi x is phi dash, because we don't know phi of x. We are going to find out. Derivative of phi x is phi dash. Okay. Now by using this equation, vx we have already calculated, and we know uy is equal to minus vx. By using uy is equal to minus vx, that is vx is equal to, take minus on that side, uy. This vx is equal to uy, already we calculated as this. Okay, minus uy, that's why minus minus gets plus. Put this value here, we get 6xy plus 6y. Now this is again a vx and this is again a vx. Comparing these two equations, we get 6xy is here, the LHS is same, that's why RHS must be same. By comparing, what we have to find this, 6xy is here, 6y is also there, that's why phi dash x must be 0. Okay, because these are two equal, these two are equal. Now phi dash of x is equal to 0, we want phi of x, that's why to cancel out derivative, dash means derivative effect, take integration on both sides. Now integrating, we get phi of x, derivative integration gets cancelled, integration of 0 is 0, and plus we have to find, it is only the single valued function, it is our normal integration. While it is we are taking integrate, here we are integrating with respect to y, because x is also there, here only x is there, that's why we have to add 0 plus c, integration constant c, that is equal to c. Okay, now put this phi of x is equal to c here, this is our answer. Okay, that's why we get from 1, this is 1, v is equal to rest of the terms as it is, phi of x value is c. Okay, this is the second function from here. That's why the answer for find corresponding analytical function f of z is but nothing but u plus iv. U is already we have given u here, put that as it is, plus I into v, just we calculated as this. This is the answer. In some example they can ask just find v, in some example they can ask for finding analytical function. That means this is the only difference. Okay, let us see such type of examples more. Find analytical function whose imaginary part is this. Okay, now what is our function? Let us start. Let f of z is equal to analytical function, that is u plus iv. And what is the real and imaginary part? This is real part, this is the imaginary part. Okay, find analytical function whose imaginary part is given, that means v is given, this, that, and let v is equal to e raised to x, x sin y plus y, this is given. Okay, find analytical function means we have to find this, v is given already, that means we have to find u, other variable. In earlier example u is given, we have to find we found v, and this example v is given, we have to find u. Okay, the similar process. Let us start. V is equal to this. Okay, to find out the integration derivative, take e raised to x inside to this bracket, we get this u. Our question is find u. Okay, now take derivative first of v with respect to x and with respect to y. Now differentiate 1 with respect to, this must be 2, x and y first. Okay, differentiate this equation 1 with respect to first x and then y. V with respect to x, v by x, y constant. Here x into e raised to x, we have to take derivative with respect to u into v rule, sin y is a constant, u into e raised to x, derivative is e raised to x, plus v into derivative of x is 1, plus here y into cos y is a constant as it is, e raised to x derivative is e raised to x. Now simplify, take x multiply throughout the term, so we get derivative of y by derivative x. X is x e raised to x sin y plus e raised to x sin y plus y e raised to x cos y. This is derivative by derivative x. And again derivative by derivative y we calculate as same like this, differentiating this equation with respect to y, keeping x constant obviously. What is that? W by w y, x e raised to x as it is, sin y derivative is cos y, plus e raised to x is a constant as it is, y into cos y derivative we have to calculate as regarding u into v rule, that is y into derivative of cos is minus sin y plus y, v into that is cos y into derivative of y is with respect to y is 1. Multiply throughout, we get this term as it is. This is minus y e raised to x sin y. This is again plus e raised to x cos y. These are the two derivatives from here. Okay. Now we are going to use the CR equations. But by CR equations, ux is equal to vy and uy is equal to minus vx. Okay. That's why this is, you can start from this or this also. Okay. In either way you get the answer. Now uy is equal to minus vx, that's why I take minus, this is vx as it is vx. Okay. Now what is next process? To find what is our motto, to find out u, we get w by y. That's why taking to find, to cancel out this derivative effect, you have to take integrating both sides with respect to y. What we get? U is equal to, now taking integration of this term, with respect this term to with respect to y, here minus x e raised to x as constant, and sin y integration is minus cos y. Okay, integration for all formulas on the of derivatives and integration you have to mug up. Okay, sin y integration is minus cos y, minus minus gets plus here. Now plus e raised to x as it is, sin y integration is minus cos y, minus minus becomes plus, minus as it is e raised to x with respect to y we are taking integration is constant as it is, and y into cos y we have to take the integration with respect to u into v rule. Okay, what is u into v rule? U v integration is u v1 minus u dash v2 plus u double dash v3 minus u triple dash v4 plus, and so on. This is the basic chain rule of u into v rule. U into v1, suffix means integration, dash means derivative. V1 means first integration minus u dash derivative of u. V2 means its integration again, that is v2 second integration, plus alternating plus minus sign. U double dash take on derivatives of u and take on integrations of v. Okay, use here, we get here u into, what is u and v, how to define that? By Liet rule. Okay, this is trigonometry. This is cos y is a trigonometry, y is a arithmetic term, x or y is arithmetic term. That's why this is u, this is v. U into v rule. Okay, u into, first one is u into v1, u into cos y integration is sin y, plus take derivative of y is 1 here, no need to write 1, and sin y integration is minus cos, that's why minus minus becomes this sign plus here. Now next term will be plus u double dash, means one derivative is 0, that's why this process ends here of u into v rule, bracket complete, plus obviously this is the integration with respect to y, and x is also there, that's why we have to write plus c, but here we have to write plus function phi of opposite of y is x. Okay, now simplify first, just remove all the brackets, we get this term as it is, minus y into e raised to x sin y minus e raised to x cos y, plus this is phi of x. Now x this as it is, this term gets cancelled. Okay, this term as it is plus phi of x as it is, call that equation number 2. this one we get u. Now what is our motto? To find out phi of x. Now already we used this equation, one equation. Now we are going to use this equation here. Okay, now for that, in this equation ux is there, that's why you have to differentiate this equation with respect to x to get u of x, because already we know we have y here. Okay, differentiate above equation with respect to x. What we get? W by w x, y constant obviously, cos y is a constant, u into v rule here, x into e raised to x plus e raised to x into derivative of x is 1, u into v rule, u into derivative of v plus v into derivative of u, plus minus as it is, derivative with respect to x we are going to take y sin y as a constant, e raised to x derivative is e raised to x, plus phi x derivative, we don't know what is phi x, so we have to find out that, that's why take derivative means phi of dash x. Okay, now take this term inside this, we get these two terms, minus y e raised to x sin y plus phi dash of x. Okay, now this w by wx is this, and from this CR equation ux is equal to vy. That's why this is ux implies is equal to, you can write as it is, ux is equal to vy, that is equal to this total term as it is. Now we know this is equal to vy, that means you can write that as it is, implies, in detail you can write out as this ux, x e raised to x cos y plus e raised to x cos y minus y e raised to x sin y plus phi dash of x is equal to vy. What is vy? This term, total term, x e raised to x cos y minus y e raised to x sin y plus e raised to x cos y. Okay, now comparing these two equations means these two equations, what we get? Both the terms are same here. Okay, three terms are same here, that's why phi dash of x is equal to 0. Okay, you can write this step here. That's why taking, we want phi of x, that's why to cancel out derivative effect, take integration on both sides, we get phi of x is equal to 0, derivative 0, plus we have to add constant c, integration constant. Put this value here in this answer, what we get from 2, u is equal to this total term as it is, two terms, and phi of x value is c. This is our answer. Okay, that's why analytical function f of z becomes u plus iv. This is equal to u is this plus I into v is already given in the example. Okay.